All right, let's talk about one of the biggest headaches in software. How do you get dozens, or even hundreds, of different programs to talk to each other without creating absolute total chaos? Well, today we're going to break down a really clever solution that you'll see works a lot like a real-world post office.
Really think about it for a second. Let's say you're building a massive environmental simulation. You've got one piece of software modeling the weather, you've got another one handling plant growth, and a third one for soil chemistry. They're all specialists, right? They're experts at their one job, but they're also completely isolated. How do you get the weather expert to tell the plant expert that, hey, it's starting to rain? How do you coordinate that potential chaos?
And that right there is the coordination challenge. Our source material gives us this perfect example, a simulation where all these different parts need to constantly exchange data and sync up. The weather simulator has to let the plant simulator know it's raining, and in turn, the plant simulator needs to tell the soil simulator, hey, I'm soaking up all this water. But how do they actually do that?
Now, your first instinct might just be, well, let's just connect everything directly to everything else. But trust me, that way lies madness. You end up with this fragile, tangled web of connections that's an absolute nightmare to manage. If you change one little piece, you might have to go and fix 10 other pieces that were connected to it. It's messy and it just doesn't scale. The whole thing breaks down the moment you try to add something new.
So, how do we fix this tangled mess? Well, the source code we're looking at points to this really elegant solution, and we're going to call it the digital post office. In the code itself, it's a class called the simulation message bus, and believe me, it is the key to solving this entire coordination problem.
Just think about how a real post office works for a second. You don't walk a letter over to your friend's house yourself, right? No, of course not. You drop it in a mailbox, and you trust the postal service to handle all the complicated stuff, the sorting, the routing, the delivery. The simulation message bus does exactly that, but for software. It's this central hub that manages all communication, keeping everything neat, orderly, and incredibly efficient. And just like its real-world counterpart, our digital post office has three main jobs. First, it has to register all the simulators using the register simulator method. This is basically giving every program an official address so the post office knows where it lives. Second, it receives all the incoming mail through the publish method. This is anyone dropping a letter into the system. And third, it processes and delivers that mail, which is what we see in the _process event method. It's a simple, powerful, three-step process that just works.
Okay, so we've got our post office set up, but now we have to think about the mail itself. You can't just scribble something on a napkin, drop it in a mailbox, and expect it to get delivered, right? You need a standard format. An envelope, an address, a stamp, a letter inside. So let's take a look at what's inside our digital envelopes.
In this system, that standard format is called a simulation event. You can think of it as the official standardized envelope for every single piece of data. Every message that goes through our post office has to use this exact format. And that's what makes the entire system so reliable.
And each of these messages has a very clear structure. The event type is basically the subject line of your email. Source simulator, that's your return address. Target simulators is where it's going. The data, well, that's the actual content of the letter. And priority, that's like slapping a big urgent stamp on the envelope, telling the post office to handle this one first. This structure, this is how you bring order to the chaos.
And the system is built to handle a whole bunch of different subject lines, or event types as they're called here. You've got everything from simulation start and terminate simulation to more specific things like a state update or a data request. Having this predefined list of topics is absolutely crucial because it lets the post office sort all the incoming mail with incredible speed and accuracy.
Okay, so we've met the post office, we've taken a close look at the mail. Now let's put it all together and see how they actually work together. We're going to follow a single message on its journey, all the way from the sender to the receiver.
The whole journey kicks off when a simulator subscribes. It basically raises its hand and tells the post office, hey, anytime you get a letter with the subject state update, I want a copy. Put one in my P.O. box. Then, some other simulator publishes an event. It creates a new state update message and drops it off at the post office. And finally, the post office does its job. It processes the message, sees the subject line, checks its big list of subscribers, and delivers a copy to everyone who asked for one. It's clean, simple, and super efficient.
And this clear separation of roles is really the secret sauce. On one side, you have the post office, the simulation message bus. It's a passive player. It doesn't create any messages itself, it just manages and routes them. On the other side, you have the citizens, the individual simulators. They're the active ones, sending mail, receiving mail, and actually getting their specialized work done. Now, as cool as this simulation system is, this whole digital post office idea isn't just for simulations, not even close. Now we're going to zoom out a bit and see why this exact pattern is a fundamental building block of the modern digital world we all live in.
That's right. This model, often called a publish-subscribe pattern, or pub-sub, is one of the most important concepts in large-scale software design. What you've just learned isn't some obscure niche detail. It's a core principle that literally powers huge chunks of the internet.
Seriously, once you see this pattern, you start seeing it everywhere. Your social media feed updating in real time, that's a Pub subsystem. Real-time stock tickers, notifications from your smart home devices, even the servers that run massive multiplayer online games. They all rely on their own version of a digital post office to keep millions of things coordinated and in sync.
So here's the crucial point, the big takeaway. By decoupling these systems, by making sure they don't have to be directly wired together, you give them freedom. The weather simulator can get a major upgrade, and as long as it still sends and receives the same kind of mail, the plant simulator doesn't even have to know or care. This flexibility is what allows developers to build and maintain these massive, incredibly complex systems that we rely on every day.
So, it turns out the humble post office gives us this incredibly powerful way to organize chaos. It's an elegant solution that connects all these separate, specialized worlds into one seamless working whole. The only question left is, what complex world will you connect next?